Hello and welcome to Electro Nerds Academy. In this video, we're diving into writing conditional statements, commonly known as if-else statements. In our daily lives, we routinely utilize conditional statements. For instance, if it rains, we grab an umbrella. Here, rain serves as the condition, and if it holds true, we take the action of using an umbrella. Therefore, in any conditional statement, the condition plays the most important role as it determines the next steps in decision-making. In programming, we define conditions using comparison operators. These operators function similarly to what we learned in elementary school, but their notation in programming is slightly different. First, we have the less than and greater than operators. Then, there are the less than or equal to and greater than or equal to operators. We also have the not equal to operator, which is written using an exclamation mark, and the equal to operator, which uses two equal signs. It's important to note that a single equal sign is used as the assignment operator, meaning when we write a equals 5, we are assigning the value 5 to variable a, whereas here we are checking if variable a value is equal to 5 or not. Now let's look at some examples of how conditions are written using the comparison operators. The first condition checks whether 5 is greater than 6, which is false because 5 is not greater than 6. The second condition checks whether 5 is less than 6, which is true because 5 is indeed less than 6. The third condition uses a variable a and checks whether its value is greater than or equal to 10. If the variable value is 10 or higher, this condition evaluates as true, otherwise it's false. Similarly, the fourth condition also uses a variable a and checks whether its value is less than or equal to 10. If the variable value is 10 or lower, this condition evaluates as true, otherwise it's false. The next condition checks whether variable a is equal to variable b. If both variables have the same value, this condition is true, otherwise it is false. The last condition checks whether the variable a is not equal to variable b. If both variables have different values, then this condition is true, otherwise it is false. Now that we have seen how conditions are written, let's move on to the syntax of the if-else conditional statements. It begins with the if keyword. Within parentheses, we specify the condition we want to evaluate. If the condition is true, the code within the curly braces following the if statement executes. Conversely, if the condition is false, the code within the else block executes. For example, if we check if 5 is greater than 4, which is true, so the code in the if block will execute. However, if our condition checks whether 5 is greater than 6, which is false, then the code in the else block will be executed. While we can include multiple if statements in our code, only one else statement is permissible. If none of the if conditions are met, the else statement executes. Alternatively, we can also omit the else statement and solely employ if statements. Now let's consider an example where we check in which range our variable a falls into. If its value is between 0 and 10, code A should execute. If it's between 10 and 25, code B should run. And if it's between 25 and 50, code C should be executed. So to achieve this task, we have written this small program. Here we have 3 separate if statements. The first if statement checks whether A is less than 10. If true, code A executes. The second if statement checks whether A is less than 25. If true, code B runs. Finally, the third if statement checks whether A is less than 50. If true, code C executes. At first glance, this may seem correct, but let's examine what happens when we assign different values to variable A. If A is set to 45, the first 2 conditions are false, but the third condition is true, so only code C executes. This works as expected. If A is set to 15, the first condition is false, but the second condition is true, so code B executes. However, when the Arduino checks the third condition, it is also true, since 15 is less than 50. This means both code B and code C execute, which is not what we intended. The issue becomes even clearer when A is set to 5. Now all 3 conditions are true because 5 is less than 10, 25, and 50, so the code block of all 3 if statements run. To fix this, we introduce the else-if statements. These statements allow conditions to be checked sequentially in a structured manner. Their syntax looks something like this. It is always started with an if statement followed by as many else-if statements we want. Here, the program first checks the if condition. If true, it executes the corresponding block of code and skips all other conditions. If false, it moves to the first else if condition. The program again checks the condition. If true, it executes the corresponding block of code and skips all other conditions. If this condition is also false, the program continues checking subsequent else if conditions. This process continues until a condition evaluates as true or all conditions are checked. Now let's see how using else if statements resolves our initial issue. We will replace the second and third if statements with else if statements. And we will set the value of variable a to 5. Now, when the program starts, it first checks the initial if condition. Since a is equal to 5 and 5 is indeed less than 10, this condition evaluates to true, and code A is executed and the remaining conditions are ignored, ensuring only one block of code runs at a time, which is exactly what we wanted. Now, let's change the value of a to 15. The first condition is now false, since 15 is not less than 10. So the program moves to the next else if condition. This condition evaluates to true as 15 is indeed less than 25. So code B is executed, and the rest of the conditions are ignored. The else if structure ensures that as soon as a condition evaluates to true, the remaining conditions are skipped, preventing multiple blocks of code from executing. So the else if statements are great when we have to check our conditions in a structured manner, one after the other. But what if we want to check 2, 3, or even more conditions in a single if statement? For example, if we want to check whether variable a is less than 5 and greater than 1 using a single if statement. In that case, we can combine conditions using logical operators, and, or, and not. So let's start with the and operator, represented by 2 ampersands, which ensures that all conditions must be true for the overall expression to be true. For example, here we have 2 conditions. The first one checks whether variable a is greater than 10, and the second checks whether a is less than 20. Placing an and operator between them means that the whole expression will be true only if both conditions are true. If either condition is false, the entire expression evaluates to false. So if we place this whole expression inside an if statement as shown and assign variable a value of 15, then the if statement is evaluated as true because 15 is both greater than 10 and less than 20. However, if the value of a is changed to 25, the if statement is evaluated as false because although 25 is greater than 10, it is not less than 20. And since the and operator requires both conditions to be true, the overall expression is false. Next, we have the OR operator, which is represented by 2 vertical lines. The OR operator requires at least one condition to be true for the whole expression to be evaluated as true. If both conditions are false, only then does the expression evaluate to false. So if we replace the AND operator with an OR operator in the previous example and assign a value of 25, the code inside the if block will now be executed. This happens because even though the second condition is false, the first condition is true. And since the OR operator only requires one condition to be true, the overall expression is true, and the code is executed. The NOT operator, represented by an exclamation mark, negates the output of a condition. If a condition is true, it makes it false, and if a condition is false, it makes it true. For example, if we check whether 5 is less than 6, the condition evaluates to true, meaning the code inside the block will execute. However, if we place a NOT operator in front of the condition, it will reverse the result, making the condition false, and the code inside the block will not be executed. That's all for this video. For more such content, visit our channel and check out our website for in-depth tutorials and code. The link is in the description. Finally, don't forget to like, share, and subscribe, and we will see you in the next one.